What is a fault map? A fault map is a type of geologic map that displays the distribution and location of geological faults within a specific area. Faults are fractures in the Earth's crust where movement has occurred, and they are commonly associated with earthquakes and other types of seismic activity. A fault map provides a visual representation of the faults and their characteristics, such as the direction and amount of displacement along the fault, the type of fault, and the age of the fault. Fault maps are useful for a variety of purposes, including earthquake hazard assessment, natural resource exploration, and land use planning. Fault maps are created through the interpretation of geological data, such as field observations, satellite imagery, and geophysical surveys. The data is then compiled and analyzed to create a detailed picture of the fault system within a given area. The information presented on a fault map can help researchers and engineers better understand the risks associated with earthquakes, which is particularly important for areas prone to seismic activity. This understanding can be used to design safer buildings, infrastructure, and transportation systems. In summary, a fault map is a critical tool for geologists, seismologists, engineers, and planners to better understand the geological structures of a region and to make informed decisions about the use of land and resources. How to create a fault map? Creating a fault map requires a combination of fieldwork, laboratory analysis, and data interpretation. The following steps provide a general framework for creating a fault map. Gather data. The first step in creating a fault map is to gather data about the geology and fault systems in the area of interest. This can include field observations, aerial photographs, satellite imagery, geophysical surveys, and existing geological maps. Conduct fieldwork. Fieldwork involves making observations and collecting data in the field. This can include mapping the distribution of rocks and geological structures, measuring the orientation and characteristics of faults, and sampling rocks for laboratory analysis. Analyze laboratory data. Laboratory analysis can provide additional information about the rocks and geological structures in the study area. This can include analyzing the chemical composition of rocks, identifying mineralogy, and dating the age of rocks. Interpret data. Once all the data is gathered, it must be interpreted to create a comprehensive understanding of the geology and fault systems in the area. This can involve identifying patterns in the data, constructing cross-sections, and creating 3D models of the geological structures. Draw the map. Using the interpreted data, a geologist can create a fault map that displays the distribution and location of faults in the study area. The map may include information on the type of fault, the age of the fault, and the direction and amount of displacement along the fault. Update the map. Fault maps must be updated periodically as new data becomes available. This is particularly important in regions with high seismic activity, where new fault systems may be discovered or existing faults may be reactivated. Overall, creating a fault map is a complex and interdisciplinary process that requires a combination of fieldwork, laboratory analysis, and data interpretation. The resulting fault map provides a valuable tool for understanding the geological structures in a region and assessing the risks associated with seismic activity. Please don't forget to subscribe to my channel and turn on notifications.